Welcome to a quick video explaining how we can prove a squared minus b squared equals a minus b times a plus b using a visual method and talking about area. So I'm going to start by, here's my a squared, here's my b squared. Those are represented by areas. They're squares. So a squared would have dimensions a by a, and b squared dimensions b by b. And if I'm going to do a difference of squares, well, what that means is I'm actually cutting away the b squared. I'm actually removing that much area from the a squared. And if I did that, I'd be left with something like this: a squared minus b squared. Now, if I want to talk about this, so I can remove my original ones, and I'll come back, I'll talk about them later. If I could find the area of this, I could have some sort of statement maybe to prove that the area is equal to a minus b times a plus b. Okay? And I can't do that in its current form, because it's a little bit awkward. It's not really a shape I'd have a formula for. But what I maybe notice is I have two rectangles. If I cut along this line, I'd have a rectangle up here and a rectangle up here, and something really nice happens. So I get out my scissors, snip, 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 and I have it cut into two pieces, where I have a bottom rectangle and I have my rectangle up there. And I've gone ahead and I've labeled their dimensions, and that's going to be important later. Okay, what I notice is these rectangles perfectly match up, and I'll talk more about that dimension later. But where I got these dimensions, as I said, along the bottom, well, that's just the bottom of the original big square, a dimension of a, so I can label the bottom with a dimension of a. And up on top, that's just the side of b squared, so that's where I get my dimension of b. Okay, so if I were to place this as a rectangle here, I could talk about that entire bottom dimension, b, sideways, but b, and a. So altogether, a plus b. Okay? And then this side dimension I still have to figure out. Well, let's go back to the original orientation. That was the removed chunk after I took away b. So it was this full side length of a removing the side length of b, or another way to say that would be a minus b, a removing b. And it's the same thing up at the top. I can look at it the same way. That top dimension was the whole thing of a, but I removed b, which is why this side dimension lines up perfectly with the rest of my rectangle. And there you have it. Oh, I drew this in the wrong spot. Okay, this side dimension, I have dimensions of a plus b and a minus b. So if I wanted to find the area of this thing, I would say it's base times height, or it's length times width. It's a rectangle. A minus b times the other dimension, a plus b. And there you have it. This original shape, a squared minus b squared, okay, represents the same value as a minus b, a plus b, and that is your visual proof of the difference of squares formula.